Okay, all right guys, so this video we are going to start with the properties of limits, okay? So here are the 6 properties of limits. Now, to start with number 1, I'm going to give you, my pen's not working. The limit of f of x as x approaches c equals to L, okay? Then I'm going to give you another one. The limit of, give you another function, g of as x approaches to c equals to m. So this is saying that the limit of these two functions as x approaching c is the same value, they do exist. So property number 1, it's called the sum rule, okay? So can I add them? Yes, you can. Here we go. The limit as x approaches c of f of x plus g of x is the same thing as if you were to find the limits independently of f of x as x approaches c and then add it to the limits as x approaches c of g of x. Then that means it's the same thing as saying L plus m. Okay, so when you're looking for the limit of the two functions adding together, you can find them independently. That means you can break them up and then add them together at the end. So that's the sum. You could also do the same thing to the difference. Okay, the difference. So the limit as x approaches c, what if I want to do f of x minus g of x, like that? Well, you can find them independently and then subtract. So the limit of f of x as x approaches c, take away the limit as x approaches c of g of x, okay, which means it's just L minus m. Then, same thing with product. So product is, so if you have the limit as x approaches c of f of x times g of x is the same thing as if you were to find them independently, then multiply the result. Oops, limit as x approaches c of g of x, okay? That means if you have the results already, you can just take L times m. Then you can also have constant multiple. So the next one is constant multiple, okay? So what does that mean? If you have the limit as x approaches c of some constant, let's call it k, times your function f of x. This is the same thing as just taking k times the limit of f of x as x approaches c. So what you want to do is, let me get yellow highlighter. You can technically find the limit of that first and then multiply to k. Well, if you already know the limit of f of x as x approaches c, which I kind of gave you up here, then you can just take the constant times L. Well, what happens when you have a quotient? Can you divide? Sure, okay. Quotient rule. So when you have the limit as x approaches c of f of x divided by g of x, you can break them up independently, find them first, and then divide. Okay, so if you don't feel like doing g of x as x approaches c, okay, if you already know the limit of f of x, which I gave you earlier as L, the limit of g of x was m, you can break them apart and then find them after each limit. Then the last rule is power rule. As the limit approaches as x approaches c of f of x. Okay. Now, what if I were to raise it to a power of p? This is the same thing as if you were to find the limit first. Okay. Then raise it to the power p. That means if you already know what the limit of f of x is, in this case I gave you L, it's the same thing, it's L to the p. All right, so those are all the rules. So now we're going to use them in example 5. Okay. Assume that the limit as x approaches b of f of x, which now I gave you, equals to 7. Then the limit as x approaches b, those two b's are the same, of g of x equals to -3. Determine each a, b, c, and d. So here is part A. Find the limit of f of x plus g of x as x approaches b. Now, based on your addition rule, I can find the limit of each independently as long as it's reaching the same b value, and then add them at the end. X approaches b. Well, I already know what that is. The limit of f of x as x approaches b is 7. The limit of g of x as x approaches b is -3. So this final answer, it's actually 4. Now, same thing with b. When you have two functions multiplying together and then it asks you to find the limit, the rule said you can break them up. You can go limit of f of x as x approaches b times the limit of g of x as x approaches b. You already have the answer to each one in the problem itself. The limit of f of x is 7. The limit of g of x is -3 as x approaches b. So this final answer is -21. Okay. Now we're on the next one. C is a constant multiple. Remember the rule said if you have a constant times that's being multiplied to the function, it's the same thing as saying 4 times the limit of g of x as x approaches b. Well, I know the limit of g of x as x approaches b, right? That is already known. So this is pretty much saying 4 times the limit as x approaches b of g of x is -3. So this is going to be -12. Okay, so here's the next part. I want you to do D on your own. Okay, again, I want you to do D on your own. So if you are listening right now, you should be doing D. When I'm coming around to stamp your video notes and D is incomplete, you will not get a completion stamp because that means you're not listening. So if you're listening, you should be completing D on your own with an answer box up. Okay. Our next theorem is called a sandwich theorem, or some books call it the squeeze theorem. And this theorem is good. Okay. So only needed if finding the limit of a function that oscillates. Okay, what does that mean by oscillating function? So here's an x and y coordinate plane. A function that oscillates, meaning that it starts out really wide and then it gets closer and closer in the middle and then it starts back out wide again. Okay, so typically a function that oscillates, meaning that it's kind of looking like this. Okay, it starts out wide and then it keeps changing all the time. Okay, it changes every time that x changes. Okay, so what is the theorem for the sandwich? So again, some books will call it a sandwich theorem and some books will call it a squeeze theorem. Here's the theorem. If g of x is less than or equal to f of x, which is less than or equal to h of x. Okay, so that's if. On the same interval, let's call this inclusive interval from a to b. And the limit of g of x as x approaches some value called c is exactly the same as the limit as x approaches c of h of x, which let's call it L. Okay, so if those two limits are identical, then the limit as x approaches c in the middle, which is f of x, also needs to equal to L. Okay, so here's why this is called a squeeze theorem or a sandwich theorem. Usually when you think of a sandwich, the middle, right, part, we have to have a middle part. So what if I can't find the limit of f of x? Okay, so what's happening is that in an oscillation, sort of a function, the y value are never the same coming from the right or the left, or I wouldn't say never. You have a hard time of finding the height, okay, coming from the right and the left. So we use the sandwich theorem. What we're saying is that if the right side, okay, and the left side are identical in its limits, okay, again, if the right side and the left sides are identical, let's call it L, then the limit of the middle has to also be the same because it's being squeezed or because it's in the middle of the same value. So that's what we're going to say for the sandwich theorem. We will definitely apply this, okay? So here are the steps. Okay, I'm going to spell it all out for us. Are you ready? Use the sandwich theorem to find the limit. Here we go. The limit of x squared times cosine of 1 over x squared as x approaches 0. Woo. All right. I'm going to write it all out for you. Are you ready? First, let's try substitution method to see if I can find the limit. Now, if the substitution method works, then I don't have to use anything, right? So let's find it. Limit as x approaches 0 of 0 squared times cosine of 1 over 0 squared. Oh, Houston, we have a problem. Can I have 0 in the denominator? Okay. This is not possible. Not possible. So here are the steps in using the sandwich theorem. Step 1. I'm going to work it out and then I'll spell it out down here. Okay, step 1. Take the trig apart. Find its max and min. That means this is the range. Okay? All right. So, our step 1, the trig is the cosine. So take it apart. So what I mean by that is cosine of x. That means, hey, what's the parent function of your trig? Cosine of x. Then you need to tell me the range of the cosine of x function. So the lowest value of the range is -1, that's your min. The highest value of your cosine of x is 1, that is your max. That's your range. Step 2. Down here, we are going to spell out what we're going to do. Step 2. Multiply or divide or add or subtract, whatever operation you need to do, remaining parts. to the entire inequality. The entire inequality. That means all three parts. Okay, so here's what we're going to do next. Would you agree that in your function, I have 1 over x squared? So I'm going to need to go in, right, and change that. Again, I need to go in and change that. In addition, you also have this x squared being multiplied to the cosine function. So I'm going to go in, but here's the thing. This right here, it's a vertical change. Okay, this is a vertical change. So that will only affect the range. So right now, I'm going to go in and multiply this by a -1 times x squared. And then in the front of this, this is x squared times cosine of x. Then this one is 1 times x squared. Can you see that I'm multiplying x squared to each and every inequality? But this one right here, that's a horizontal change. Okay, if it's a horizontal change, the ends, which is the range, don't change. So really, this stays as a -x squared less than or equal to x squared cosine 1 over x squared, and then less than or equal to positive x squared. Again, this right here, okay, those right there, it's a horizontal change. On the outskirt, this right here, okay, those are the range. So the horizontal do not affect the range, only the vertical change will. So right now, this is what we have on our inequality. Okay, I went in and I multiply to all three parts of my inequality by x squared. Step 3. Find the limit. So I'm going to write down here, step 3. Find the limit of the left and right side. Okay, so let's do that. Step 3. Find the limit of the left, limit at x approaches 0 of a -x squared. And then find the right side, limit as x approaches 0 of positive x squared. Those two, well, I can plug in 0. I can use substitution. Okay, so this is an upside down parabola. As x approaches 0, the height is going to be approaching 0. Same thing on the right. It's an opening up parabola, so the limit is also 0. Last step, step 4. Step 4. Most important, make your final statement. Make final statement. What do I mean by that? Based on your sandwich theorem, if the right side has a limit of 0, the left side has a limit of 0, then obviously the middle function, which is this guy, right? That middle function should have the same limit. So the limit as x approaches 0 of x squared times cosine of 1 over x squared must also be 0. Okay, so this is the most important step because this tells me what your final answer is. Now, all 4 steps will be required, okay, but the final step is where your answer is going to be. Okay. I only have just 2 more things and then I'm going to end the day. Now, before I start this, just so I know who's listening and who's not listening, here's a sort of an 8-year-old joke, okay? This is what my kids will come home and tell me kind of a lot of times. What did the boat say to the pier? What did the boat say to the pier? What's up, Doc? So if you're listening, I want you to write that joke down. That may be one of your questions on your homework quiz. Now we are going to do a special limit, which you will need to memorize. Okay, limit, here we go. The limit as x approaches 0 of sine of x divided by x is always 1. So important, super important. Memorize that. Now another one that you need to memorize is another limit for the future. Ready? The limit as x approaches 0, here we go, cosine of x minus 1 all over x equals to 0. Okay, so this is another one that you would need to memorize for the future. We will prove these in the future. Right now, I want you to memorize these two. So the one that you're going to need to know immediately is the limit as x approaches 0 of sine of x over x equals to 1. Now, the one in the future that you're going to need to know is limit as x approaches 0 of cosine of x minus 1 all over x equals to 0. Now, memorize those two. In addition, don't forget to write down your joke. This is the end of our notes.